Welcome. This is a demonstration of our OSP software, or Obstacle Service Planning software. This is by Finn Bonset from Simtra Americas. This is our new software package, and the idea is that we want to demonstrate the FAA and ICAO obstacle clearance services, or also known under FAA as Part 77 imaginary 3D surfaces. As you can see, the program works in AutoCAD. We have an actual OSP menu box here, a drop-down menu. And as you can see, also we can set up a few things here, but I want to demonstrate just the functionality of the program and what it does. So let's say that I have a need to create a runway environment with all of the Part 77 services for FAA or ICAO, and I need to create, for example, the horizontal service, the conical service, the approach service, etc., etc. So the way that I go about doing this is I'm going to simply create a runway. First, it's going to ask me to save my drawing, obviously, so I'll just save this on my desktop. Okay. So once I save the drawing, it'll ask me whether I want this to be in imperial measurements or in metric measurements. You have the option for both, so if you're doing international work or domestic US work, you can use either one. But for today, I'll use the imperial units, which means feet. We can also choose an airport reference point, or simply we can go into the drawing and create our runways. So basically, if you have a runway environment already in, for example, an airport layout plan, all you would need to do with your first point to select the runway itself would be to snap to that point or give it the coordinates. So let's just imagine that we have a runway in this direction of, let's say, 10,000 feet, and we have a width of 150 feet. There we go, standard 9 Group 5 runway. Just give it a second. Okay. So I'm going to zoom out, and that way you can see what I've just drawn. So this, again, if you had an airport layout plan, of course you can put those coordinates anywhere that you want. So what happens is the runway numbers are obviously designated right away. We have a length and a width that we just entered, and now we also have to enter some runway details. So if I click on runway details, what's neat about this is where we can choose, for example, the runway end elevations. So let's say we have an elevation at the start point, which is runway 07 of 10 feet, and maybe we have a 5-foot difference of 15 feet at the other end. What we can also do is we can create points in between. So if we have different runway points with different elevations, we simply click on add, and we can choose anywhere on a line. Excuse me, we need to pick point. There we go. We can draw on this line. So that's one point there. We can enter that Z elevation. Maybe we call this 16 feet. It's going to be a strange looking runway. Just going to remove that one there. And you can do that as many times as possible so you can get accurate with your transitional surfaces. Then we can also add, if we have, for example, displaced threshold. Let's say we have a 1,000-foot displaced threshold. We can put that in there. We can put stopways in there and clearways as well. This will, of course, determine your declared distances. So if I wanted to see those, I could actually click on this little box called Schema. And it also shows you all of your declared distances. So that's a nice little tool just to use and make sure you've got the correct runway environment for your airport situation. Okay, so let's say I'm happy with all of these numbers here. I'm going to click on OK and just let it calculate just a second. So the next thing I need to do in order to choose the correct Part 77 surfaces, I also need to specify the runway classification. So whether it's for aircraft approach category A through D, or E, excuse me, so let's go with D for this one. We can choose the aircraft class, which is what's large or small, and we can also choose our design group, which is not really relevant to Part 77, but it will be a future addition in terms of creating a runway for those specific standards. Also, you can see here we have runway classification, visual through non-precision or precision instrument. We have the categories. Now that doesn't really matter for Part 77. However, we do intend to apply approach lighting systems at one point, so we've added a category as well. So let's say I want a precision instrument runway. I'll click OK. Okay, and I'll click OK again. And just for fun, let's go ahead and also add another runway. And I'll make a crossing runway, just to show you the complexity of the program and what it can do. So let's head one in this direction, maybe 9,000 feet. and we'll give this one a width of 100 feet. Okay, so we have a typical crossing runway, like maybe in an older field, as typical in some areas in the United States. So I'm going to leave everything the same for this one, except with the runway classification. Let's keep this interesting. I'll make this a aircraft approach category C. It'll be a large airplane. We'll keep design group 3 here, and we'll make this a non-precision instrument approach with, let's make it a runway larger than utility with visibility minimum requirements greater than 3/4 statute mile. Again, just to show you the ability that we can choose that. So I'll click OK. Okay, then I'll click OK on this one as well. And now obviously what we really want to see for these two runways are the surfaces. So the next thing I'm going to do is on the icon menu here, I'm going to click on Create Obstacle Limitation Surface, or OLS. Okay, this is where I can select my surfaces. Of course, automatically the primary surface is already created, but let's give this a different color. I'll click on Conical, Horizontal, Approach, Transitional. You also have the ability to choose your obstacle free zones. And then what I'm going to do is click on Create and let the program calculate the surfaces for me here. This probably takes about 20 or 30 seconds. It's a little bit slower because I'm creating a video with a certain type of software. But anyway, the idea is that the surfaces are created in 3 dimensions at a much faster rate than what it would take if you were just to design this with AutoCAD and you have to create each individual contour. So we'll just let this calculate for a little bit longer. Should take about 5 or 10 more seconds. Almost there. Again, once you have crossing runways, things usually take a little bit longer to calculate. If I had a simple one operation type runway or a parallel runway system, the computations are a little bit less complex and it's a little bit faster. But okay, looks like it calculated it for me here. So I'm going to close this so we can take a look at what we have. I'm going to do a zoom extents here. And now as you can see, it's created the basic dimensions. You can see here we have our precision instrument approach surfaces, and we have our non-precision approach surfaces right here. So that was pretty fast. Okay, well this is just the bare bones of it. Let's say, for example, I want to see the contours of or elevations at contours so that I can determine obstacle clearances if I have them. So now I'm going to simply click on the surface itself, and within a few seconds it automatically creates the contour lines for all the surfaces, as you can see in the drawing now. So if I zoom in a little bit, you can see now, for example, here's my 50-foot MSL contour for that approach surface. I've got all my transitional contours, 50 or 100. Again, you can set those contour intervals as small or large as you want, depending on what your requirements are, and you can set that up in advance. Okay, now it's not 3D yet, but I want to show you the 3D capability of this as well. So let's go into our visual styles. I'll go into my view menu here, and let's make this a little bit nicer of a picture. So I'm going to conceptual. So AutoCAD will convert this to conceptual. And now what I can do is I can go back into my view command, use my 3D free orbit, and look at the surfaces in a 3-dimensional perspective. So there you can see, for example, there are your contours for your Part 77 transitional surface. You can even look at it this way. There we go. So you can really see it's in 3D all the way through. If I wanted to take a look here, my apologies, there we go, my computer takes some time to render it, there we go. There we go, so you can really see the different dimensions in each corner. Okay, so that's quite neat. However, what if I wanted to see some 3D objects? What if I had objects around my airport? Well, I could insert them by myself if I had 3D objects, or I could have point data be imported into the program from either Excel or Notepad type files, or I can place objects myself. So I'm just going to undo a couple of clicks here, and what I'm going to do is I'm going to create a building, and I'll give it a name. I'll call it Test 1, for example, and let's make it a skyscraper. Let's make it a 1,000-foot building here. I'm going to click on Create, and let's place that building right in the approach surface, right about there. And it first asks me what type of building I want. I'm going to keep this a polygon, so I'll type in G for polygon. The center of it's right here, and let's give it quite a big radius, something like this. Maybe 8 sides will do on this one. Okay, now, there you can see the obstacle itself. Okay. Now, that's not a pretty picture because it's, of course, 2D at the moment. It's a top-down view. But what we can do is we can find out where the penetration is of the nearest portion. So if I click on this on the actual surface with this tool here, I can zoom in and it'll tell me, okay, at this point, the height of the surface and the object is 303.56 feet, and it's penetrating by 696.44 feet. Okay, and I can actually export that to a really nice table by clicking on Overview Intersection of Objects. So if I take a look at it, for example, it tells me the actual object, the object height, the height of the surface at the object, and the penetration, and also the surface on which it's penetrating. So if you had 100 obstacles, it'll tell you exactly what those obstacles are, and I'll give you all that information. Nice little feature. However, what if I want to see this, again, this object in 3D? Okay, well, let me go back to my same methodology. I'll go to Visual Styles. Let's make this conceptual just for now. I'll go to my orbit, use a free orbit, and now when I move this, you can see the object coming into place here. There's my 3D object. Now this is quite crude, and this is just a simple creation, but if you had certain 3D objects, whether they're in Civil 3D or another type of program, you can get as fancy as you want with this. You can have it as a house, you can have it all different types of objects if you so desire. There we go. Let me just move this a little bit. There we go. So for example, if you wanted to view it from this angle, there's your object over here. Here you can see the surfaces. Now if you wanted to see the object penetrate through it and you want to see the base of it, what you could also do is you can go to your Visual Styles and go to your Visual Style Manager. Okay, and what you can do here, let me just move this along. There we go. Under Conceptual, you can also change the opacity. So if I put this on 25, for example, now you can kind of see through the object, even if I were to put this on 10. There we go. Now you can see the whole object, where the intersection is. You can kind of see the surface penetrating. Again, you can play with the colors and make this as fancy as you want. We can even make it conceptual if we look at the object that way and make it, there we go, give it an opacity of about 60. Something like that. You can see the object through the surface, and again, you can get as fancy as you want. You can put images under it. The program will detect different types of mountains. It'll detect any type of 3D object that you need for this project.